Somewhere out in space, there is an object so heavy that nothing, not a rocket, not light itself, can ever escape it. If you got too close, time would slow down around you. You would stretch into a thread thinner than a strand of hair, and the universe would watch you fall forever. This is a black hole, and almost everything you think you know about them is about to get weirder. A black hole isn't a hole and it isn't empty. It's the exact opposite. It's too much stuff crammed into too little space. Picture taking a star far bigger than our sun and crushing it down smaller than a city. The gravity becomes so extreme that it punches a dent in reality itself. The edge of that dent has a name, the event horizon. Cross it, and there is no coming back. Not in 1,000 years. Not ever. And here's the first strange part. The event horizon isn't a wall. There's nothing physical there. You could drift across it and feel absolutely nothing, right up until you realize you can never leave. But what happens to time as you cross it? Hold that thought. Let's do something nobody should ever actually do. Let's fall into one. As you approach, gravity pulls harder on your feet than your head because your feet are slightly closer. At first it's gentle, then it's not. You stretch and stretch. Scientists have a real official word for this: spaghettification. You would be pulled into a long, thin string of atoms. But here's the truly bizarre part. To you, falling in might feel fast, but to someone watching from a safe distance, you would appear to slow down and freeze. Glowing red, hanging at the edge of the black hole, seemingly forever. That's the strange truth. Near a black hole, time itself bends. The closer you get, the slower your clock ticks compared to everyone else. A black hole doesn't just trap light, it traps time. Now let's zoom out, because the scale is hard to even picture. The black hole at the center of our own galaxy, called Sagittarius A star, is about 4 million times the mass of our sun. And it's just sitting there, in the middle of the Milky Way, with everything, including us, quietly orbiting around it. But that's a lightweight. The biggest black holes ever found are billions of times the sun's mass. We call them supermassive black holes, and we still don't fully understand how they got so big so fast. And the first ever photo of one? It took a telescope effectively the size of the entire planet to capture it. 8 observatories across Earth, working as one giant eye, just to photograph a shadow 26,000 light years away. Here's where it stops being cool and starts being genuinely unsettling. At the very center of a black hole, our math gives an answer that should be impossible: a point of infinite density and zero size. We call it the singularity. And the honest truth? Physics breaks down there. Our best theories of the universe simply stop working. Then there's an idea from Stephen Hawking that flipped everything. He showed black holes aren't perfectly black after all. They very, very slowly leak energy, now called Hawking radiation. Which means black holes aren't forever. Given enough time, far longer than the current age of the universe, they will evaporate. They will die. And one last mind bender. When something falls in, the information about it doesn't seem to fully disappear. It may get smeared across the surface of the black hole, as if the inside of a black hole is somehow written on its outside. Scientists are still arguing about this one today. So let's go back to the beginning. That object so heavy nothing escapes it. It bends light. It freezes time. It stretches you into a thread. It hides a point where physics itself gives up, and eventually even it will fade away. The strangest part of all? There are likely millions of them scattered across our galaxy alone. Silent, invisible, waiting. If your mind just bent a little, that's the universe doing its job. Follow along because next time we're going somewhere even stranger.